Hi, everyone. My name's Hugh Karp. I'm the founder of Nexus Mutual. So a little bit of background on myself. I'm the corporate insurance guy that caught the blockchain bug a while ago, and have now kind of worked out how to do insurance on blockchain in a mutual fashion. So I'm an actuary, got 15 years experience in the insurance industry. Just left my nice cruisy job doing CFO for Munich Re's life operations in the UK. For those of you who don't know, Munich Re's are one of those huge companies that no one really knows about, so it's a reinsurer. It's got 33 billion of premium income. So I guess that kind of tells you two things. Hopefully it gives you some confidence. I know what I'm talking about when it comes to insurance, but secondly, the market for insurance is absolutely huge. And blockchain is a good way, and it's always been talked about as one of the major use cases of blockchain. So hopefully this is one way we can make it work. So I'll start with a bit of a story. So 2000, 3000 BC, Chinese trading merchants used to basically put their goods on boats and go down the river and basically enable trade. That's how they move their goods around. But they had a problem as a community. They had a problem. There was often rapids, and basically the goods would get lost or destroyed, etc. So as a community, they basically grouped together, and the merchants decided to shift different goods onto different boats. So they would basically all share their goods around on the different boats. So that if one went down, then they only lost a tenth or whatever of their goods. And so that meant quite a lot of things. It meant that as an individual merchant, you were more resilient. You could you were only exposed. You were less exposed to being totally wiped out. You could also, instead of only purchasing some goods and then transporting them and keeping a reserve yourself, you could take more risks. You could use more of your kind of capital, built up funds, and take more risk, and then enable trade a bit more. So this is like one of the first examples of mutual insurance, of the community recognizing a problem, coming together, sharing that risk together, and becoming more resilient, and then enabling greater trade and everyone being better off. So that's kind of what we're trying to recreate now that we have blockchain technology. So that model was good, but one of the big problems was it couldn't really scale very much. So we put in place insurance companies to essentially link different groups, link the Chinese trade merchants with the, I don't know, other village over here that was insuring life insurance for different people. So those two groups couldn't talk to each other before, but now we have blockchain technology that allows them to talk essentially together without the need for an insurance company to link them and become that intermediary. So that's what we're trying to do. So I'll start with the product, and then I'll go back to the platform and kind of how we're operating it. So Ethereum community. That's the community we're targeting first, and the problem that we're trying to solve is smart contract security. So it's obviously a real barrier to adoption. We've got, if you're a user, how do you know that if you're trying to interact with a smart contract, how do you get that confidence that the money's just not going to disappear? If you're a developer, you're going to can be quite scared of actually hitting that deploy button to mainnet and going, oh, hold on a minute, if this has a bug in it, we've gone through security audits, but if this has a bug in it, what are we going to do? So it's also a really hard problem. And there's a lot of really smart people working on this, but you can go through testing, you can go through security audits, multiple layers, you can go through bug bounties, but you can never be 100% sure that there's not something there. So from my perspective, we need redundancy in the solutions as a community. So, and this is where the combination of solutions comes in play. And essentially what I'm saying here is we've got the prevention, which should be the primary focus, which is what a whole bunch of really, really smart people in this room and in this conference are working on, and we're not doing that. But formal verification, testing tools, standardizing code, security audits, all of that, it all needs to happen, and we need to get better at doing that, and that's great. What we also recognize is that you can never get 100% satisfaction or comfort that all of that will work. Even with, as an example, even with formal verification, if you can prove that the specifications operate as intended and you actually go through that formal verification process, that's great. But there's the other part that's missing, and that's the validation. And at the end of the day, when we're coding stuff, we have to get our intentions out of our heads and write it on pieces of paper or in code or whatever, and then you have to write those specifications. So you can test that the specifications get validated and operate as intention, as you intended to, but what about that first step? Did it come out of your head right, and did you write the specifications correctly? So we're saying that prevention should be what we're absolutely 100% focused on, but we also think we need a cure, a safety net, if things do go wrong. Okay, that's great, but okay, how do you actually assess claims? At the end of the day, what we're doing here is we're introducing a human layer onto the code. So what we're covering against is unintended usage of the smart contracts that leads to a financial loss. And that's really a human interpretation. So as an example, like the DAO hack or the parity multi-sig wallet issues, I think it was pretty clear in all those circumstances that wasn't the intention of the code. It wasn't the intention of the DAO to be able to, it was the intention to be a autonomous investment vehicle in a whole bunch of different projects. It wasn't the intention that someone should be able to just drain it for funds. Same with the parity multi-sig issues, is obviously the intention to keep funds secure. It wasn't the intention that someone could just hack it and take all the money. So you can argue whether code is law and all the rest of it, and that's fine, but I think it's pretty clear that the intention of the code did not work in that case. And that's the idea. That's what we're trying to cover against. And you can't code that. You have to have people to assess it. So we're providing that human layer, and so we're providing a decentralized claims assessment method to actually assess that. Now, that has a whole lot of benefits. It has some disadvantages as well. One of the big advantages is that it's product agnostic. We can actually write our product on a piece of paper. So the product that we're building, smart contract cover, can just be, did it have unintended code usage that led to financial loss? And people can interpret that how they will. So it doesn't require a trust of an external oracle. We're not restricted to the parametric covers. And that's quite important, because parametric will become bigger and bigger and bigger as an insurance aspect of the insurance industry over time as more and more data sources become available. But at the moment, most of the cover written, the vast majority, is actually indemnity-based, which means if you got your house and there was, and part of the kitchen burned down, you don't get paid for the whole house, you get paid for the kitchen. You lost part of it, not all of it. And then that requires interpretation by humans to be able to do that one. The other quite important thing is, because we are voting and everyone's a member of this mutual, we're legally not classified as insurance in the UK and in other countries, which means we don't actually need an insurance license or the regulatory framework around it. We're essentially just sharing risk amongst each other. So this isn't insurance. It's called discretionary cover, and it's provided on a mutual basis. These entities exist today. What actually we are doing is taking a defined legal structure, automating it as far as possible with smart contracts, and then just fitting in with that existing legal structure. So disadvantages, it's harder to implement. You've got a voting system with incentives and game theory and all the rest of it. It's potentially more vulnerable to attacks. And the one thing that we haven't been able to solve just yet, that we're hopeful in the future, but is that we're not fully decentralized. While the voting mechanic and the first part about is the claim valid is decentralized with the voting. The problem is that insurance claims assessment is quite hard. And it's you don't necessarily want to punish people just for having a difference of opinion, but you want to punish people heavily if they vote fraudulently. So determining what the difference is between, oh, you just got a different of opinion, or if it's fraud, that's very hard. So we're centralizing the decision-making on was that a fraudulent vote or not. We think there are solutions in the future, but we're going to start a bit simpler with a centralized bit to start. So I'll talk a bit more about the platform and then kind of how it works in each of the different aspects. So we're trying to replace that insurance entity with code. So at the moment, we've got a current model of the insurer where you've got all of these services that are grouped together, and they provide all of those. So you've got your underwriting, your pricing, your capital, what you do with that capital, investment management, product development, governance, claims assessment, all of that's all under one tent. And so what we're trying to do here is break it apart, commoditize each function, and make it very cheap to operate. So we will automate what we can, and then essentially decentralize the rest, and we'll use token incentives to essentially incentivize the work of, for example, people in this room, to provide work to the system to make the whole thing operate. So we will automate some of the underwriting. The investment management will be automated. The claims assessment, as I discussed, that'll be decentralized. The capital provision, that's essentially decentralized, so that's effectively a crowd fund. And then we'll have voting processes on the governance, and we'll also have the pricing and underwriting is actually split. Some of it's in the middle, some of it's like an automated algorithm, and some of it's decentralized, and I'll get into that in a bit. So the big, one of the big things here is that we will need a whole bunch of external work to be provided to the system to make it operate. So we have to incentivize those through token incentives. So one of the clear ones here is capital provision. Insurers need a whole bunch of capital to operate. They essentially sit on that money and pay it back to the members or to the people that are insured in the future for claims. So this is a kind of a well-known one in crypto, obviously. You can have a token model and crowdsource some money. So one of the interesting things that we're trying to do, we'll actually use a continuous token model. So we'll be constantly open. And so the price will keep going up. And basically, it will go up slowly until we've got enough capital to back the contracts that we need. And then it'll start going up very steeply, basically saying, we don't want any more money, don't give it to us. We've got enough to fund what we want. And then over time, when we write policies, we go, oh, hold on a minute, we've got lots of policies in force, therefore we need more capital, therefore we'll drop the price of the tokens to encourage more capital to come in. So it's very dynamic, and the model is trying to have an efficient capital allocation and making sure that we only raise money when we need it and we don't over-raise. So if you compare that to, say, just a regular like ICO where you go, well, we'll raise like, okay, 50 million, and then we may not be able to go back at a later point. What happens is you over-raise capital to start with because you might need it in the future, but then you can't go back at the end necessarily. So what we're saying is insurance companies need ongoing capital as they grow, and this is a much more efficient way of deploying that capital. In addition, you'll be able to lock your tokens to participate in surplus distribution. So if basically we generate profits and we don't need any more capital, then we hand that back to the members, that's their share. Basically this whole thing's a membership company, and instead of the profits going to the shareholders, they go to the members of the, effectively, DAO. Claims assessment. So as I said, incentivized voting. Basically you stake some tokens as a bond, and then you can lose them if you vote fraudulently, but it's kind of like the mining operation in a mutual. Basically you vote and then you get more tokens if you vote with the consensus. Underwriting. So one of the obvious questions here is, how the hell do you price this thing? how the hell do we determine what price we should charge for smart contract A versus smart contract B and all the rest of it? So we'll have a two-tier pricing approach represented by those two lines. So the first tier is essentially a automated algorithm that's very conservative, that's trying to replicate how battle-tested is this code? How long has it been on mainnet? What funds does it have? How long has it been exposed to a hack and it hasn't been hacked? And so basically the price starts high, very high, probably uninsurable, so a bit not very helpful to start with, but then over time it becomes more reasonable. So that's obviously going to work for some contracts out there that have been on there for a while, but it's not going to work for a whole bunch of other ones. That's where the second layer comes in. And here, effectively what we're doing is incentivizing and crowdsourcing smart contract security expertise. So if, as an underwriter, a smart contract auditor, say, you have the skills and you want to assess that particular smart contract and you think it's secure, then you can stake some value against it in the form of tokens, and for every sale, every cover that's bought on that particular contract, you essentially earn commission income. If there's a bug if there's an early bug, then you stand to lose some of your stake, but otherwise you earn essentially commission. And as a result, the price drops to a much more reasonable level. So that's kind of how we're trying to crowdsource the underwriting expertise. And this actually mimics the approach like Lloyd's of London use in their models. They basically have capital providers that will back an individual expert who underwrites a particular cover, particular insurance. So, for example, if you're a smart contract auditor but you don't have much capital, then someone may back you, and then you can come to an arrangement with them to about how you split that commission. So we're trying to mimic, through smart contracts, how the insurance industry works at the moment. In addition, there's a governance function. Basically, this whole thing is it's a DAO, and it's completely upgradable and changeable, etc. So you can vote on proposals, you can put proposals forward, and that would be like product upgrades, changes to parameters, or in an extreme event, if things go really bad, then you can vote to shut the whole thing down and basically distribute the funds to the members. And the membership does have full control over this thing. One of the interesting things is what we're doing is there are legal structures that actually allow this to happen, and so you can write articles of association for a regular company and have it operate in this way. And this is how mutuals kind of operate at the moment. So that's kind of just the talk. I'll just quickly kind of build up how it goes through to kind of give you a little bit more idea of how it kind of fits together, because there are basically a lot of different elements that come together to make the whole thing work. So there's one capital pool where the money goes in that backs the contracts. And the first step is, as a member, you put in Ether to the pool, and there is a token model, and you get some tokens. So that's that curve. Basically, you get more tokens at the start and less tokens at the end when it's well capitalized. Then, okay, you've got your tokens. What can you do with them? So the first one and most obvious one is you actually destroy them to purchase some cover on a particular contract. So you're just a regular customer. And so if you just want to be a regular customer, you don't really care what the token price model is, because all you're doing is you're buying Ether, then you're for tokens, and then you're destroying tokens to get cover. So if you take those first step to the end, all you've done is put in Ether and got cover. So you don't care what the price is. And so everything here, and this kind of goes back to what Christoph was saying earlier around the volatility of cryptocurrencies. Volatility is actually a relative concept. So at the moment, because and this is one of the reasons we're starting with this product, is we're going to denominate the cover in Ether, because that's generally what people are interacting with smart contracts. So we're going to have a pool of Ether of assets backing its liabilities in Ether. So volatility is not an issue. One Ether is one Ether, one Ether. So because of that, we're just totally kind of within the cryptocurrency space rather than having to worry about the fiat aspects. we've built the platform to actually be capable of taking in like stable coins once they get a bit more established, and therefore being able to write cover that you need in a real world for your washing machine, as an example. So, but we'll start with something that's denominated in Ether. Anyway, so you've got your cover. That's one option. That's what you can do. We've got the pricing model that sits mostly off-chain. So, second one, as I explained before, you lock your tokens for participate in the claims assessment, and if you vote with the consensus, you get more tokens, and then the claims come out of the pool and go to the member who was suffered from the hack. Bit more complicated now. So you can lock your tokens for surplus distribution. Now the idea here is, as with the token model, we're going to have this off-chain capital model. So the way insurance companies work at the moment is they have to work out how much capital do I need to hold to be very confident that I'm not going to go bust. And there's a whole bunch of regulations to work out how you do that, and there are standard models that, for example, Solvency II, there are standard models that tell you how to do that, how to do those calculations. What we're doing is replicating that exact approach, and we have to run that off-chain because it's just way too complicated to put on-chain. So that introduces trust elements. You know, I guess from our perspective, we want to be fully decentralized, but we can't quite get there yet because of technical limitations. So we'll start with something that has some centralized elements and then try to improve it over time. So anyway, going back to the capital models, you've got this capital model. Basically says this is how much you need to hold based on the policies you have, and then that determines like your minimum capital level. And then we'll just do a ratio, say 180% of that minimum capital. Once the funds in the pool get to greater than that, then we'll start distributing surplus. Kind of like a dividend, but legally it's a surplus to the members. So that goes to the members based on the token holdings, essentially. And yeah, you can lock your tokens to get access to that. And the idea here with one of the key themes you'll see running through the token model is that you need to, insurance is all about risk sharing. And risk sharing happens over time. Risk is incurred over time. So if you lock tokens, then you're exposed to that risk over time. So the whole idea is if the more you lock your tokens, the more rewards you get out of the pool in return for taking on more risk. Yep, and then the last one is being able to lock them for underwriting. So actually there should be a feedback loop into the pricing model effectively. So yeah, you lock your tokens, as I was describing before, as the stake on the bond, and then you earn commission income in the form of extra tokens. So basically, if you want to just be a customer here and just purchase tokens, burn tokens, and get some cover, that's fine. You will be a small member, and you'll still be entitled to some of the future profits, but you will effectively get slightly diluted by everyone else who's actually a more active member of the mutual providing work to the system. So every one that's providing work to the systems gets rewarded with extra tokens, which is essentially a share of the combined pool, the combined capital pool. So it's this balancing act between that you can play on the passive side, you can be more active, you can choose what you want to do, you can choose to be any of those options. And so if we take that back to what the insurer model is, basically, we do everything in one box, going back to that slide from a little while ago. What we're doing is we're breaking it out and allowing different experts to participate as they see fit in the items that they're more skilled at doing. So we commoditize those functions and basically strip out massive layers of cost from the whole system. At a high level, the economics of insurance works that basically you only get 65–70% of your premium back in claims. The rest of it gets taken away through extra costs in the system and profits to shareholders, etc. So based on this model, conservatively, we think we can strip out at least half of that tax. And the rest of it actually just goes to the members because there's no shareholder here. It's all, everyone owns it together. So that's basically it. We're using the smart contracts to bring back the peer-to-peer mutual. We are We will, when we launch, which is hopefully be before the end of the year, but we'll see. We will launch with a live product, and then essentially the first stage will be the raising of the capital pool. So it will launch with something live, and you'll be able to use it from day one. Yeah, so that's us. Thank you.
If there is any question.
Hello, thanks for the presentation. You mentioned your product includes governance mechanism and that people will vote on upgrade, on which contracts to use and everything. Can you talk a bit more about that? How are you going to structure this? Is it only going to be votes? Will you have administrators? Do you have a model for the governance you're going to be using?
Yeah, we'll use a very simple model to start with. Basically, there will be well, legally we'll actually have a board. We have a real company that sits around this. So there'll be a board of, say, 5 people that effectively will whitelist the proposal. So anyone can propose something, but they get whitelisted by the board. And then the first step is that the board will assess the proposal and provide a recommendation, basically a yes or a no, what they think. And then they will push that to the membership base to decide what they want to do. So every proposal will come from a recommendation from so-called experts, but then the membership base can decide which way they want to go on it. And it's just a token-weighted vote. I guess there are a few extra elements to it, but one thing is the board will be able to, and this is another slightly centralized aspect, the board will be able to do some things by itself, primarily emergency actions. One of the things we have implemented is an emergency pause button, which basically just says stop all transactions happening. To basically, if there's an issue, it'll give us time to build something and then switch from this smart contract to this one over here that's actually fixed if there's a bug. So there will be some kind of emergency actions that the board can implement by themselves without pushing it to a full member vote. Cool. All right. Thanks, everyone.